Okay, this video is going to be on how stars evolve. And this has to explain how we end up with the different types of stars: main sequence stars, red giants, and white dwarfs. So all stars start out as a giant cloud of gas. It's mostly hydrogen. And then gravity pulls it together. And if it has enough mass, hydrogen fusion and we'll talk more about hydrogen fusion in a bit. When the hydrogen fusion starts, we end up with a normal star. And if you remember, another name for normal stars or main sequence. And that happens when hydrogen fusion and gravity balance. Okay, gravity is always trying to crush it, but the energy from the fusion pushes out. And when they balance, you have a steady state star, and the star can stay that way for millions of years, billions of years for some. All right, eventually though, the star runs out of hydrogen, so it can't fuse hydrogen anymore, and helium fusion starts. And what happens next depends on the mass. If it has a low mass, like the sun, it turns into a red giant. And if it has a high mass, it will become a supergiant. Now, these low mass stars all follow the same path. Eventually, they get to the point where they can't fuse anything else. And when they do that, gravity is going to collapse the star. And it just becomes a white dwarf. All right. And a white dwarf, there's no fusion going on anymore, so there's no energy source. It's white because it's hot, because as it shrank, it got hotter and hotter and hotter. But since it doesn't have a power source anymore, eventually it's just going to cool off and it's just going to become cold. And that's called a black dwarf star. Now, high mass stars, after they become supergiants, they get to the point where gravity can't fuse anything else again. Gravity's going to collapse the star. And when that happens for these, they're so big that that collapse is so dramatic that it causes a giant explosion called a supernova. And again, we're going to talk about those in a little bit. And if it has kind of a medium mass, okay, so like 1.5 to 3 times the sun, you end up with what's called a neutron star. Okay, it actually takes the electrons and the protons and squishes them together. And if you get an electron and a proton, a positive and negative together, it's going to be neutral, and it turns them all into neutrons. So it's an entire star made up of neutrons. And if it's a high mass, okay, then it's going to turn into a black hole. It collapses so that it's so small that gravity gets so strong that even light can't escape. Now a little bit more on the main sequence stars. And we referred to this before. Energy from hydrogen fusion balances gravity. So the fusion inside pushes out. Gravity is still trying to collapse it and pushes in. And when they're balanced, that's when we have a main sequence star. What hydrogen fusion is 4 hydrogen combine into 1 helium, releasing energy. And this is the power source for main sequence stars. Now, color and lifetime. Okay. Blue, these are the hottest, and red are the coolest. Okay. These burn hydrogen fast. Down here, they burn more slowly. And burn isn't really the right word if they're fusing it, but we can think of it as burning it. These run out of fuel. So kind of in this column, we're going to have the lifetime of the stars. These might only be like 10 million years. So actually very, very short. Now the sun is a yellow star, and it can last for 10 billion years. Okay, and our sun has been around for about 5, so it's about halfway through its life. And these red ones can last for hundreds of billions of years. And then the very end of this star's lifetime, it's going to run out, or sorry, not the end of its lifetime, the end of its main sequence stage, it's going to run out of hydrogen. So fusion stops and the star becomes a red giant or a supergiant. All right, and we'll talk about those in our next set of notes.